Hello, my name is Caitlin Chapman, and this is my Lab 5 video report, which we decided to do on collisions. So a little bit of an introduction for it. The main purpose of this lab was to create a model and real-world example of momentum being conserved in an inelastic collision, and we used two plates from the gym and the CRC for our collision. And the principles that we used were the conservation of momentum, which means that the change in momentum is basically going to equal zero. And we also used Newton's second law, which is like position, velocity, momentum update formulas. And a result preview is that our computational model did well in predicting the motion of the two plates. And so a member in our group recorded a video of the two plates colliding, and they were rolled directly at each other, and we analyzed that video in the tracker system so we could use that data to create a computational model in GlowScript. And our system was the two plates, and the surroundings were the earth and the hands that pushed them. And these are two images of the code that we created. We first set our initial position, time, change in time, our velocity vectors, and then we calculated kinetic energy, set two while loops to run through to update the position and the momentum as it went through. And yeah, we did that using Newton's second law and the momentum principle. And these are our results. At the top of the screen, we have the data from the tracker system, so that's our actual data that was collected. And then the two pictures below are from the computational model that was going to predict what was happening. And they represent the system pretty well. We can see how it's got the two different plates and they're somewhat equal and opposite. And a potential error that could have been in this experiment is that we're not usually making our GlowScript from scratch, and so that was a change that we had to adapt to. And it was also hard for us to account for some of the energy that was lost due to friction. And for the what if questions, we had to come up with these on our own. And so for what if, I thought I might consider what would happen if we changed up the masses of the plates so that they weren't the same, and then we could clock them at the correct initial speeds. We definitely would see a change in the graphs and the data, but the procedures would remain the same to collect that data and create the model. And for what does it mean, I wanted to discuss why the collision was just inelastic and not like perfectly inelastic or just elastic. And so due to the plates being rolled on the floor of the gym, there's a lot of friction on this surface, which means that there will be energy lost and kinetic energy won't be conserved. And also the plates don't stick together at the end of the collision, so therefore the collision is just inelastic. All right, thank you.